So good morning, everyone. And this is, we've been doing some exploratory study around zero trust. And I thought I'd come and share my learning experiences with you. It's a continuous journey. And we'll hope to, meet again at some point of time in the future. So quickly going through the agenda for today. We'll cover the basics. What's zero trust? What's the principle? What are some of the high-level architectural concepts? And I'll share some of the insights that I have gained by looking into, the SPFE and SPIRE framework. And we'll cover a few mythbusters about, how people approach security and what are some of the hindrances that we see against, the zero trust adoption. Some terminology, and always, it's always good to start with history, which sets the context of which helps us understand where we are today. So basically, zero trust is as defined by NIST. It's a collection of concepts and ideas. It's not like a technology that you use and implement, but it's more like a framework and a concept of ideas designed, to minimize uncertainty in enforcing accurate least privileges access decisions in information systems, and in the face of a network being viewed as compromised, right? So experts say that this is the new ABC of security, which means assume nothing, believe no one, and check everything, right? May sound very may sound very paranoid, but that's we'll see why that is the case, and why we should remove trust from enterprise scenarios, right? So one of the earliest possible prototypes of zero trust came from the Jericho Forum, whose mission was to basically define cybersecurity under deparameterization trends and to find solutions, right? And that has evolved so far, and we'll see where we are today. And it was a term coined by John Kinderbeck, who was a Forrester research analyst. And basically, he's saying that you're proven guilty until proven otherwise, right? So normally we say assume innocent till proven guilty, but I think the foundation or cornerstone of zero trust is that you're proven guilty until you are proven otherwise. So you have to establish the trust, and you have to keep maintaining that trust. So that's the basic concept here. So some of the basic principles or tenets include basically you must provide secure access to networks. Companies must and we can understand the relevance of that in the past 2-3 years that have really changed the landscape of how we work, right? So we have seen several challenges, and companies have come across really very interesting scenarios, right? We have friends, or we have multiple people living in the same home, accessing corporate networks from the same wireless, from their wireless networks, right? So it brings new challenges to the enterprise. So it's like, if we are not properly covered there, then we can have a breach of trust, and you can have people working for competitor companies working from the same Wi-Fi network. That's a possibility that opens up with the with the forced work from home scenario due to the COVID pandemic situation. So it kind of suggests that obviously becomes a basic need for companies to provide secure access to their networks, and no matter where you're logging in from, right? So the second aspect is earlier we used to assume that once you are in the corporate network, you can access whatever you want, but then that's again no longer a valid assumption, and we need to control access. And number one, they should be exposed only to the services that they need to access, and they have authorized to utilize, right? And basically, continually there must be monitoring of the traffic to ensure that the users are doing the right things, which means auditing and audit logs become primary requirements of a zero trust platform, right? Moving on to why do we need to do this, right? So traditional security has always been what we call a castle and moat, or a perimeter-based security. So basically what this means is once you enter the corporate network, once you authenticate yourself and get into the corporate network, then then you are kind of in the network, right? Then you are in the trust boundary. So the earlier the trust boundaries, as what we call, would be the corporate network, right? So it was assumed that all the entities or identities or the roles and actors within a corporate network are trustworthy. And time and again, it has been proved that this is no longer relevant, right? So the thing with castle and moat or perimeter security is it's hard to obtain access from outside, but once you obtain access, you have access to all the resources within the network. So basically, what it means is once an attacker manages to get inside a network, we know all the phishing attacks. You could the head over the shoulder attacks, or exploiting vulnerabilities, malwares, or what we call social engineering attacks, right? You just send innocuous links, you get people to disclose their identity, and once you do that, the attacker or the malicious actor always has access to all the resources that are authorized for that user, right? So that means to remain competitive, your businesses will need to build a zero trust architecture to protect their enterprise data, and wherever the users and devices are, right? With your BYO case, and now our mobile phones have become an extension of our laptop, and most of us can do a big chunk of work on the mobile phone, right? We take Teams calls on mobile phones. We use mobile phones for emails, and sometimes we can run presentations from our mobile phones as well, right? So they have evolved as well. So that means every corporate user is not using one device, but at least two minimum devices to access the data within your enterprise. So that means you need to ensure wherever your users are using the devices, you need to ensure that number one, the data is secure, and number two, the application can work quickly and seamlessly. Almost all of these collaboration tools today, right, have really evolved. Like, for example, if you're working with Teams or Zoom in this case, or even Google Meet, you can seamlessly switch between in the meetings from between your laptop to your mobile without any of the participants rather just basically figuring out where you are actually logging into the meeting from, right? So the other aspect of that is there are some research articles which have proven that cost of a single breach is very high, and it's coming down due to the increased adoption of zero trust architecture. But essentially, a cost of a single breach can reach up to almost $4 million, right? So what it means is that it's expensive, and we need to invest in that to safeguard our data, safeguard enterprise data, and safeguard personal information as well, right? Based on that, the zero trust is based on a few cornerstones of the foundations of concepts of security. It's basically a collation of what we do in bits and pieces and in here and there, right? So there are different actors when it comes to zero trust. So there are the actual users, there are the devices that log in that are used by these users. There's your network traffic, the applications that you use, and obviously there is the data that that comes into picture. So based on that, what are some of the things that come up here, right? One is basically continuous monitoring and validation, right? So that assumes the biggest shift in paradigm that we have to assume is that there are attackers from both within and outside of your network. So basically, what it means is there are statistics that show that 1/3 of the security attacks that happen are happening from within your trust boundary, right? So that means the people who are trusted, people who are valid, authenticated users. So they are the source of about almost 1/3 of the security exploits that are reported, right? So that means you cannot assume that once you are within a trust boundary, you are safe. So you need to continuously assume that you need to assume that you need to establish trust, and no actor, right, user or a device or a machine is trusted by default, right? So this means that you need to keep verifying the identity and privileges for each of these device and and the actor, right? And the other aspect is that logins and connections need to time out periodically. And once established, it's not like once you have established your credentials, you're all set, right? So the one of the paradigm of continuous monitoring and continuous validation is that you are forced to keep logging in, and you're forced to re-verify your authentication and authorization levels on a continuous basis. You probably would have noticed these changes subtly in the way you access your corporate applications, right? So for example, if you are accessing your payroll, or you will payroll website, or if you are accessing your your HR portal, whether it's Workday or any of those portals that you use, you will see that if you are inactive for a while, then your corporate applications will, even though you might be inside the VPN, most of these are applicable outside VPN also today, but even if you are inside the VPN, they will time out, and they will ask you to at least prompt that, hey, your session is about to expire. Do you want to continue, or do you want to terminate the session? So that's continuous monitoring and validation. So then we have to stick to this age-old principle of least privileges and default deny, right? These are two things. So earlier, many paradigms would assume that once you log in, once you're authenticated, you have your authorization levels are not default deny, but you do have access to certain things. But by default, today the paradigm has shifted to least privileges and default deny paradigm. So what it means is your users should be given access and authorization levels only to the resources that they need to use, and at the authorization level that they need to use. Like, for example, you may have access to view some resources or modify them, but you may not be able to delete them or add new resources, right? Those kind of fine-grained, attribute-based access control and role-based access control paradigms are being enforced now. Then you actually have device access controls. You will people, the corporate networks will monitor how many different devices are trying to access the network, and ensure that every device is authorized. And you'll probably notice, right, as soon as you register your mobile device for accessing the enterprise data, then there are certain policies that are pushed onto your device, right? Like, for example, you need to lock your device, and you will now see that if you are using, for example, Outlook or Teams on your mobile phone, then not only do you have to unlock the device to access it, but you need to unlock the application as well. You need to authorize to the application also, right? So that's you can see how we've all experienced how that's evolving, right? So that's about access controls. So micro-segmentation is and prevention of lateral movement are interrelated concepts. Now, micro-segmentation basically allows you to contain the impact of a breach, right? So to say, to reduce the blast radius, right? So to say, so what it means is your security parameters and your authorization levels and your access to services are limited to smaller zones, right? Once you log into corporate zone, it doesn't mean you have access to all the corporate services, right? So within your VPN. So in a given session, your access is only limited to a certain set of relevant services. And if you need to access more, you need to re-authenticate, and you need to this thing. So what it does is, if somebody steals your authorization or a session, then the impact that they can have is limited to what the segmented area of your network, and not to the whole network. And prevention of lateral movement is an extension of that. Is basically what happens is, we see, right, if in the traditional perimeter based security, once an actor, malicious actor, gets access into your trust boundary, he can basically move within the network, gaining access to different resources, and continuing to spread havoc there, right? But whereas what happens in the new paradigm is that when a user gains access within a network, if you are trying to access another resource within the same network, you need to re-authenticate. So that way, if an actor has stolen a session or something like that, and if he tries to laterally move to access another resource or create new sessions, he will not be able to do that. The other last aspect of this is about multi-factor authentication. And multi-factor authentication, as you know, is based on three primary pillars. It's about something you know, as in, for example, a password, or something that you have, or example, a smart card, and then you something that you are. So that includes biometrics, right? Your fingerprints, or retina scans, or voice messages, or voice patterns, or whatever. So many of us, we see that today when we have to log in, you provide your to log into your VPN, you provide your domain password, and along with that you have to provide an OTP, right? So domain password is what you know, and OTP is what you have. That is basically you have a smart device or a smartphone, and your OTP is sent to the device, and based on the authentication also happens on something that you have, and that is your registered mobile number, right? So that's a very common two-factor authentication that happens. There are more paranoid systems also implement multi-factor authentications, and they add something that you are factor as well. That's like you'll have to provide your biometric access as well, and that we can see, for example, in your Aadhaar verification, right? So whenever you go to authenticate Aadhaar, you have to prove something something that you are, which is basically your fingerprinting. So these are some of the core principles of zero trust, and just expanding and learning some more methodologies and terminologies around this. So these are some of the mechanisms that we use, right? So basically just-in-time access, right? So for example, what this means is provision access to users only they have, access to privileged accounts and resources when they need it, right? Not all the time, right? And as soon as they are done using that resource, as soon as the session is completed, then access to that resource is taken away, right? If they have to reuse the resource again, they'll have to authenticate again. Then there is the concept of just enough access, which is another way of looking at least privileges. Then you are given access only to access level only to do the current job, right? So for example, if you are to view a certain, if your current session requires you to view a certain, view a certain website view access, then you will only get view access and not the right access, right? And this is another thing that we look at, right? Some of the moving to your encryption algorithms and tokenization algorithms. So one of the things we see is we need to desensitize the data and reduce the attack surface, right? So how do you achieve this? One of the latest TLS 1.3 and other encryption algorithms that we use include the ECDH, right, and the elliptical curve Diffie-Hellman algorithms. Now, basically, what Diffie-Hellman does is that earlier what we would do, you would have a encryption key that would be valid, that would be reused for all the sessions that happen between between the client and the server, right? Because what happens in your Diffie-Hellman, especially the elliptical curve Diffie-Hellman, is that you not only have a private key, but you also need to have a session key, right? So every session you will generate session specific encryption keys, and those are valid only for that session. So if somebody hijacks that session, the damage is limited to what is being accessed, what is being done within that session, and that can be done as well. So with what essentially Diffie-Hellman does is that it is designed to eliminate the man in the middle scenario. So what we mean by that is, typically what happens is if somebody gets hold of your encryption key by some some method, like some of the social engineering head over shoulder kind of method, for however you access that, you can sniff the traffic and tap the sensitive information, right? But what happens with Diffie-Hellman is, even if you get hold of a single certificate or an encryption key, then you will only be you will still not be able to access the decrypt the traffic, because every session has a unique encryption key that gets added to this as well. So that provides an additional security layer, and basically eliminates the man in the middle scenario for a almost completely, right? So then we have the adaptive policy-based management to approach for monitoring your network policies and network access and control to network resources. So basically, there are some frameworks like Open Policy Agent that allows you to to define your policies declaratively and implement them across your networks and services access level. So we have to analyze, understand the zero trust maturity model provided by NIST, which is again a better articulation of some of these aspects that we discussed. This is sorry about that. Yeah. So this is you see that basically there are 5 pillars of zero trust maturity model, and the number one is identity, right? So basically this means you need to ensure and enforce that the right users and entities have the right access to right resources and the right continuous validation and real-time machine learning based analytics. So this is a loaded sentence, right? So you can see that earlier what we would say, just prove your identity and you have access, right? All the time. But now you see how many qualifications are getting into what you can access, when you can access, how much can you access, right? So see how we are fine graining the level of access and enforcing the requirement to keep re-authenticating continuously to prove that you are the right actor and that you are not a malicious actor who obtained a one-time access to identity. So if you have done that, then the amount of damage that you can do is largely limited. So that's the foundation of identity, and this is one of the aspects we will explore in the coming slides. On how this can be incorporated into some of the microservices architectures. So the second pillar of zero trust is basically the devices, right? Now, basically this mandates that you need to inventory devices, secure all devices that are accessing corporate data, prevent unauthorized access from devices from accessing resources via continuous monitoring and validation. And this has been depending on on the level of paranoia in your corporate. We have been experiencing this for almost the past decade. For most of since the smartphones became pretty popular, and since we started accessing corporate data through our smartphones, and the paradigm of bring your own device becoming more and more popular, it becomes necessary to inventory the devices that are accessing your corporate data, ensure that they have the right policies that are that are enforced on that. Ensure that, for example, policy may be like enforcing the device to have a have a locking mechanism either via fingerprint or by a pattern or a pin based pin or a password based lock. And these are all policies that are enforced, right? And also the device, these endpoint devices are also encrypted, so that even if they are, if the device is lost and or stolen, you cannot decrypt the corporate data. You cannot access the corporate data, right? For example, almost all our endpoint devices are the disk data is encrypted, and even if it is lost, what you lose is only the mostly the physical value of the electronics, and the information of the data remains intact because nobody can really decrypt that data without proper authorization. So that's how the device security becomes important, right? And we need to see, right, this keeps extending to enterprise application architecture as well, right? So now we are talking about your BY when we deploy our applications on containerized workloads on the customer sites. We have to support the BYOK, right? That's what bring your own Kubernetes paradigm as well. So what it means is when we do that, we need to enforce that certain security policies are properly configured on those bring your own Kubernetes environments as well. So that's a generic paradigm that extends across the different domains. The third aspect is the network or the environment. And basically, this is about the micro-segmentation aspect that we spoke to localize the impact of any attack to ensure that the blast radius is reduced to as minimal as possible. So basically here we monitor the internal and external data flows using microparameters or microsegmentations and machine learning based threat protection and encrypting all traffic. So this is another big aspect, right? Security, there are two aspects always to security. There is one who's the attacker perspective, and the other one is basically your the defense perspective. Now, what we see is a lot of the attackers are using machine learning techniques for malicious purposes to break systems, right? So they analyze patterns, they analyze the times at which systems are most vulnerable, that they analyze times at which the systems are least monitored, they analyze the locations from where systems are accessed. Everything is monitored, and the attackers use these machine learning based algorithms to reduce their brute force approach or the data set, and ensure that they are always evolving, right? So that means the defense also has to evolve. So we need advanced machine learning based technologies that act similar to the similar to the malicious attackers, and analyze some of these patterns of data access and locations, timings, and all those things, and then ensure that all of those are covered as well. So that becomes a very that's an evolving job. It requires continuous monitoring and management of your network configurations. The next aspect is application workloads, right? So agencies or companies should ensure that the application layer is secured as well. And basically, this is achieved through continuous access authorization, strong integration of security into your application workflow. So this is something that we will try to explore in the coming slides. And the last aspect is data, right? How do you protect these covers aspects of how do you inventory your data? How do you categorize and label your data? How do you store your data? How do you back up your data? How do you put it in a vault, and how do you retrieve it? All those aspects of data protection and data backup. And along with that, there are two aspects. When we are dealing with data, we're talking about data in transit and data at rest, right? So for example, when we say data in transit, we already spoke about the Diffie-Hellman kind of advanced encryption algorithms, which ensure the security is kind of taken care of at a session level and not at a client server level, right? It's not only the client and server that has to have to ensure authentication, but the encryption also differs. Encryption keys differ on per every session, right? So that's those are the advances in how data is secured in transit. And when we talk of data at rest, now we're talking about data being stored in your data backend databases, on your file systems, on your data warehouses and data lakes and whatnot, right? So there again, there are different paradigms that are followed. Most of the traditional applications say that okay, you have access to the application server that has the trust boundary. There is access to the application server, and for example, the virtual machine or your operating system itself is the data. The disk is encrypted, So if some external actor tries to access data, the raw data from the disk, that is totally taken care of. But the trust boundary still remains within the system. Any user who has sufficient privileges on the system, who may not necessarily be relevant or authorized to access your data set, the information, you will still have access to that particular data, right? So there are multiple mechanisms to prevent that also, but more or less that trust boundary is is kind of like limited to that individual application server. So for example, if you're an administrator to that application server, you can access, and you have malicious intent, you can do a lot of damage there as well. So that's where the trust boundary has shrunk into right now. So that's about the maturity model. And let's jump into how we spoke about multiple things. We spoke about a lot of aspects of how how the attack surfaces are exposed, and how each of those surfaces can be secured, how we look at data, how we look at devices, how we look at actors in your corporate scenario, how we look at the network infrastructure, and how we look at the application workload. So these are all the different aspects of your enterprise, enterprise data, enterprise architecture that needs to be secured. And this maturity model tries to put them all together under one banner, and provide a framework which allows practitioners to define zero trust based on their requirements. So that said, let's just shift gears a bit and try to understand, as we build microservices and containerized applications, cloud native applications. I want to share some of my learnings from how we try to secure the application workloads, how the interactions within your container workloads, right? So that's where I came across the SPFE and SPIRE framework. And SPFE is basically what we call as secure product identity framework for everyone, right? This is actually a framework. This is actually a protocol. Hey Aishwarya, it's been pretty one-way traffic. Can you confirm you're still with me?
Yes, we are.
Okay. Yeah, so like I said, SPFE is a protocol or a framework that defines how to assign identities to workloads, right? And SPIRE is SPFE runtime environment. It's one of the implementations of the universal identity, as we call the control plane, for implementing security in the microservices, right? So now what this does is it extends your X509 PKI infrastructure to assign. Normally what we do with X509 is we assign identities or certificates mainly to actors, all right, mainly to users, whereas users and your client and server identities, right, which are basically your nodes. What the SPFE and SPIRE framework does is it extends that certificate-based identity to your workloads rather than your just actors and machines, right? So that's the shift in paradigm that this framework brings in, and let's evaluate how this changes the scene for us, right? So what now happens is this framework allows you to authenticate securely to common databases and platforms without APIs or keys, right, or passwords or keys. Right now, passwords, IDM, identity-based or API keys or token-based authentication are some of the most commonly used authentication mechanisms. But and we have the secrets concept in your containerized workloads, right? In the Kubernetes environments, and the maintenance of secrets itself is actually a big challenge. But what this SPFE and SPIRE framework allows us is to do away with passwords and API keys and use use certificates and pre-assigned roles to access, the interactions, secure the interactions between the different microservices. What this does is it allows us to build and extend your network service mesh to across organizations and across geographies and across deployment locations to share without having to share your keys and other things, right? So there are two aspects to this framework. So there are this with the SPFE framework, there's a concept of what we call as a SPFE SVID, right? Which is basically a SPFE verifiable identity document. So essentially, this is an extension to your X509 certificate that includes your workload identifiers, right? So there are components that support, there are different services that support the SPFE protocol, and that include, as we discussed, Spire, Istio, HashiCorp, HashiCorp Console, Kuma, etc. These kind of frameworks do support SPFE, and they can generate SPFE compliant SVIDs for workloads. And we can use application layer proxy protocol services like Envoy or Nox to consume these services, right? Now, let's see, let's dig a bit more into this Spire architecture and just look at what Spire does, right? So essentially, Spire is composed of a server and a agent deployment, right? So the Spire server is essentially ties up with your certification authority, and it uses that certification authority to assign identities to your workloads, right? Now, your Spire agents basically, excuse me, sorry. The Spire server maintains your registry of workload identities. And how do you generate the workload identity? That is generated using the components of the capabilities of the Spire agents. Now, the Spire agents expose a workload API, which can be used both to generate your workload identity and to query it and verify it. Now, the Spire agents can basically come in various form factors. If it is in a non-containerized environment, you can install it on a server or a VM or different nodes of your cluster as a Spire agent as an application. And when you're looking at Kubernetes deployments, typically Spire agents are deployed as daemon sets that run on each individual nodes, worker nodes, and provide the capabilities to access these workload identities to the WL APIs, right? So that's your overall at a high level, your Spire server and agent architecture. And there are multiple aspects to this. I will, I think, I will defer the details of this the Spire architecture, low-level details of this, probably to a future session, coupled with a demo. But for now, since we are dealing with the new concept of understanding workload identities, I'd like to spend some time trying to understand what workload attestation is, right? So basically, workload attestation process answers the question, who is this process, right? So normally we are used to the question, who is this client, who's the server, who's this user, who's this, what is his role? But when we are dealing with the workload based identifications, so now we are looking at, for example, who is this process? That's an interesting question, right? So how do you get the answer? What is the answer to that question? So the agent answers that question by, for example, you use locally available authorities, right? So who are the locally available authorities who can provide identity of workloads? So if you look at a standard non-containerized workloads, that's your Unix kernel, right? So that gives you the identity of a process, that establishes the identity of a process, whereas by different attributes, including, for example, your process ID or your multiple attributes assigned to your process. It could be your multiple C group configurations that define what you can access, what you cannot access, or it could be your scheduling, your cron jobs that are scheduled on the process that define the identity of that particular workload that is running, right? But it it is equally parallel definition of the workload identity can also be applied using the kubelet process which is running on a same node in your Kubernetes environment, right? So why I'm trying to highlight this is because we can see now that we are talking of the workload, we are talking of the process, we are talking an application or a service that we have defined as a workload, and that is agnostic. The way the framework works is how the workload identities are attested is agnostic to where the workload is running, whether it's running as a containerized workload in a pod in your kubelet, or it is running as a process on your operating system. The same architecture applies. So how does the workload attestation work? So essentially, your workload APIs request an SVID is requested from your workload API, and this your Spire agent interrogates your underlying authority, which in case your kernel or your kubelet, to identify the process ID, and then it invokes your there are what are called workload attestation plugins in your Spire framework. So this is typically a CNCF project, so it works as a CSI plugin, right? So these are all implemented as CSI plugins, and it gets the SVID of that particular workload. And then when what happens is this is from the agent, this is identity is propagated to the server, as we saw in the previous diagram, right? So the agent propagates the identity of a workload to the server, and next time a workload requests an access to another service. So like, for example, one workload could be your front end, and another, very simplistically, right? One workload could be one of the front end services, and the second, it is trying to access your backend database, and database could be another workload identity. Now, when these workload identities are registered, so when a front end, a pre-configured front end, tries to access a backend database, now the agent sees the agent sitting on the database process. It tries to, similar to your client, a identity is presented. Its identity is verified with the Spire server, and you have policies which ensure that hey, this front end process can access the database, and that authentication is passed, right? So that's essentially how the workload attestation works. So how do you put it all together? We can take an example of putting it all together using Envoy and OPA. So what's Envoy? So basically, Envoy is a L7 proxy and communication bus that is designed for modern microservices based architectures. It supposed how this fits into this whole SPFE Spire and implementing this zero trust framework is basically Envoy supports an external authorization filter, and in this case, the external authorization service is your Spire server, right? So you see how the two frameworks neatly dovetail into each other. Now, what is OPA? Open Policy Agent is another open source policy engine, and that enables you to define unified context-aware policy enforcement. And basically, it allows you to implement attribute-based access control and role-based access control. So attribute-based access control defines it's on the resource. Your access to a resource is defined by certain attributes of the resource. Role-based access control is on the user side. Role-based access control, we all know what RBAC is, right? So it's quite an old traditional concept. So if you put it all together, what happens here is you can see that we are trying to showcase a Kubernetes deployment where we have three different services. You have the web, you have the backend, and you have the DB services. and all of those are essentially, you can see they are right. They are running on different worker nodes, and you have the web envoy proxy process, and you actually have a Spire agent running on each of these, where each of these workloads are running as well. And all of these are integrated with a Spire server, which can be on this Kubernetes workload, or it can be running outside separately as well. So that's the beauty of this architecture. So once this is done, once you have all these identities established, the mutual authentication between access to these services happens via the mutual TLS, right? So MTLS is essentially an extension to your basic TLS uh, TLS protocol, where only the client authenticates the server identity. So here it's an extension to that, and the server identifies the client identity as well, along with the client verifying the server identity. And once that is done, your service interaction or the session is established, and this happens every time there is a request from across any of these two services. And then you can enforce policies which essentially say, hey, your web identity cannot directly access your DB. So that can be a policy. So if somebody from tries to bypass the process, your backend, and we all do that, right? So if you have a database, just very tempted to write a simple DB query, extract some data, and present it in the front end, right? So to prevent that, you can set a policy which says, hey, if a web actor, if a web workload, which now you see, right, we are calling workloads as actors, right? So that's the shift in paradigm that happens. So now you're saying that you can set a policy which says DB cannot be, if someone with if a workload with the web identity is trying to access the database, you don't allow access to that. So that's essentially how this is one example of how you use the Envoy and the OPA frameworks, and your SPFE and implementation using the Spire to implement zero trust. So here you can see we have zero trust established, right? So what is happening here is, if you look at this interactions here, every single every single access, every single interaction is goes through an identity verification, and you can further use your policy agent to keep re-verifying. We spoke about continuous validation, right? So if there is a long session open, you can use the policy agent to request a revalidation after a certain specified timeout, right? So that's how you put it all together. Of course, you can use different frameworks as well. You can use Istio. You can use Istio here instead of Spire, or you can use instead of Envoy, you can use some other framework like Nox or something else that implements the L7 communication bus. So that's how you put it all together. That's how you integrate a SPFE workload identity, integrate with a workload identity provider and a consumer who can understand and externalize this authorization to implement a microservices architecture where these are zero trust can be implemented. There are additional, we spoke about least privileges and we spoke about just enough access, right? So there is an interesting pattern that I'm currently exploring. I don't have slides for that, but that is about, so we discussed that if you look at this, when we spoke about, we said secure microservices communication using tools like X509 and JWT, right? So what we discussed primarily was about how SPFE provides your SVIDs using the X509 extended capability, but SPFE also supports JWTs. Now, one of the interesting patterns that you can implement with the JWT is that basically you can implement a trust broker service. So essentially what this means is, every transaction that you do in a with an application in a microservices world, it's a sequence of execution of microservices, right? For example, you have microservices A executing microservices B executing microservices C. Like in this case, we have web backend DB, right? So there are multiple microservices. Now, your your user authenticates into the system with a certain authorization level into microservice A, which is your starting point. Now, when microservice A invokes microservice B, it presents the JWT token to the trust broker service, and the trust broker service essentially determines whether that invocation of microservice B requires the authorization level that is currently provided for that JWT token. Now, if that invocation or interaction requires a lower authorization level, then the trust broker service reissues a token only for that interaction between microservice A and B, and then the service B is executed with only the lesser privileges or the just enough authorization required to execute that service, right? So, and now when microservice B executes microservice C, it presents the original token, and then again the trust broker service determines what is authorization level required for that. Obviously, that authorization level is capped by what you the level of authorization is capped by what is the original JWT token that was invoked. If anything higher is required by a downstream service, obviously the request is denied. But if anything lower is required, you are reissued a token that gives that lesser privilege, and it basically ensures that you have zero trust in that. Why are we doing this? Is because if somebody hijacks into that session of invocation of service B, then he has a lesser authorization, though the whole transaction started with a higher authorization level. So these are some of the interesting patterns and of trust brokering. Those are that are actually coming up. I haven't come across any live implementations of that yet, but that's something that's part of my learning process, and hopefully in a future session I'll be able to share that some details around that as well. So that's how that's my current state of investigation around and understanding of how we can use the SPFE and the SPIRE framework to ensure that our cloud native applications can implement zero trust security. Aishwarya, how are we doing on time? We are doing okay?
Yes, we are.
Yeah. Moving on to zero trust network architecture. This is another shifting gears from application cloud native application development architecture. Excuse me. So let's move on to another aspect of this zero trust, which is this new terminology that's becoming very popular, which is called ZTNA, or zero trust network architecture, right? So basically, this is a solution that provides secure remote access to organization data, and based on the clearly defined access control policies. Now, this essentially offers a way for users, applications, data to be interacting with each other even when they don't reside on on the organization's network. So this was basically a Gartner terminology that is designed to help eliminate granting of excessive trust to users. Again, this is around just-in-time access and just enough access that we discussed about, right? So this is basically about removing trust from from the whole architecture here, right? So what it means is it kind of reinforces the concept that nothing has to be trusted until proven trustworthy, and more importantly, you have to retain the trust, and that trust must be re-authenticated whenever anything changes about any of the actors. Like, for example, if you are having if you move from one location to other, or if you try to access the same data from a different device or from a different context, or anything changes with that interaction, you need to re-authenticate. So that's the model reinforced by ZTNA, and we notice that, right? We see that Google is already implementing that, for example, right? So if you try to log into your Google account or your Gmail from a laptop or a different device, then you have to go to your primary device and you have to say approve that. you will get a notification on your, for example, if your primary device is your mobile phone, you get a notification on your mobile phone which says, hey, someone is trying to access your Gmail account from this IP address. Do you want to approve this? So you see, right? You see how ZTNA is playing its part in our daily lives, not necessarily in corporate all our own. I'm trying to tell you that we don't need to limit our thinking only to our enterprise architectures that we design. And if you look at it that way, I mean, Google itself is a huge enterprise, right? And we are all consumers of their services, and we see that they are incorporating all of these concepts and architectures as we see how we access the devices, how we access their services, and how we access them over time, over place, from a different location. All those things changes. You need to re-authenticate at every single level. So how is this different from VPN? There are some subtle differences between ZTNA and VPN. They are not ZTNA. It's not essentially ZTNA versus VPN. It's essentially boils down to how do you further secure your enterprise by combining ZTNA and VPN concepts, right? So essentially, if you look at it, VPN is designed to offer your network-wide access, whereas your ZTNA tells you that you don't get network-wide access, but you get access to specific resources with specific authorization levels for specific periods of time. So that's essentially what ZTNA says. So what it means is it offers better resource utilization, more flexibility and agility. Right? We spoke about attributes-based access control and role-based access control, right? See, we are all used to RBAC, right? So RBAC is always about who's the user who's logged into the system, what's authorization, what's his role, what's authorization level he has on what specific resources. Now, for a certain kind of resource, a certain role with an authorization level always has same type of access level, right? Whereas what attribute-based control allows you is to define policies on the resource being accessed. So, for example, if you are designing, for example, if you have a huge enterprise which has hundreds of thousands of VMs, then attribute-based access control allows you to, or your vCenters and other, almost every other vendor these days allows you to attach tags to resources, right? This tag, and when you look at AWS and AWS-based resources, services, whatever you use, you can attach tags to them. Or attribute-based access control allows you to do is to incorporate those tags which are user defined into your access control, and then you can set a policy which says you can only access a user with this authorization level, which is your RBAC. You can say that you can configure a policy which using your OPA kind of roles, which say that can access only attributes which have these tags. That's your attribute-based access control, right? So basically, VPNs and ZTNAs are work in conjunction with each other to strengthen security of your enterprise network. So that's an additional layer of what happens along with that. That more or less. Let's look at some stories there. I think more or less completes the main content that I had. A few additional interesting pieces of information I'll share, and I think we'll try to look at Q&A after that. Google Beyond Zero was an interesting project that happened. And what happened was Operation Aurora, right? So that was essentially a series of attacks that was conducted by what we call as advanced persistent threat actors, right? So why was it called Operation Aurora? There is again an interesting history for that. What they found was that on these systems and services that were attacked, they found some files that had this name Aurora on that, right? So basically, they called it Operation Aurora, and the impact of that was multiple companies, right? Multiple companies, a lot of these enterprises, they detected that this Aurora attack has happened, right? So there are a lot of theories around political conspiracies and others around who initiated these attacks and why they did that, but we'll not get into that. But essentially what happened was a lot of enterprises like your VMwares, your Netflix, your Google, varied across varied domains, whether it's healthcare providers, telecom providers, or Google or your streaming platforms like Netflix. Almost everyone was impacted by this, and what it ensured that was multiple of these accounts and informations were compromised. Now, how did this happen? Basically, it was a zero-day flaw that with Internet Explorer. Just for just to clarify on the terminology, zero-day flaw is basically a defect in a security defect in a system which exists and which you don't know about. Right, that's what we call a zero-day flaw. So it's like you installed a software, and essentially. Um, the enterprises that deploy when you deploy application on their production environments are supposed to certify that we have done certain level of security testing, and you will get a security certificate for that, and you will get some, which says that, hey, this is free. This is free from your command injection, SQL injection, cross-site scripting, those kind of attacks. You'll essentially get a certificate, something like that. But sometimes what happens, we will discover some defects after the product was installed. People will not be aware that these defects or vulnerabilities existed earlier, and those are called zero-day attacks, right? Zero-day flaws. Sorry. And a similar such zero-day defect in Internet Explorer, along with the ability to lateral movement within the network, right? We discussed these terminologies, right? So that is what caused the operation Aurora, or what happened. And what the actor essentially did was he used the zero-day flaw in Internet Explorer to deploy malware, which kind of like essentially spread in your enterprise network, compromising sensitive data. And as a result of that, Google started a Beyond Corp initiative, which resulted in a lot of changes in Google. I think this happened around the 2013 time framework, and and we can see that a lot of these additional security aspects that we spoke about, the accessing of your Google accounts and services, have come into force, mostly during the second half of the 2010 decade, right? So a lot of these came out from the Beyond Corp initiative, and essentially this meant that access to services must never be determined by the network from which you connect. So where you connect or access a service from should not determine whether you are able to access it or not. This was one thing. So what it means is the authentication shifts from the place where you access it to where it is being accessed. So that means irrespective of where you access it, you have to authenticate it, right? So this is again always verify paradigm, right? And access to services is only based on contextual factors from the users and device. Now we spoke about how if you access your Gmail account from a different device, you get a notification on your primary device, right? That's what this means. And access to service must always be authenticated, authorized, and encrypted. And that's kind of like what we see today, right? So that's mainly about Beyond Zero. So why I highlighted this was these are what we call inflection points in these security approaches. And learning about these helps us understand, bring a lot of context into how we approach and understand security policies and the things that are happening around us. A few mythbusters, and we'll open to Q's and A's. Zero trust solves a technology problem. That's one of the primary myths that many enterprise stakeholders deal with. But zero trust essentially is not a technology problem, right? It is just a business problem, as we have discussed earlier. So, like you said, right, John Kinderberg, who was one of the pioneers of zero trust, he says, if you don't know your business needs, you will fail. This is, it may sound pretty obvious, but we'll be surprised how many times we fail because of this reason, right? So, for example, if you are a senior architect, or if you are in a customer facing mode, or if you are a customer facing role, then you will understand, right? When you interact with customers, many times they don't know what they want from your product, and you will have to work with them. You will have to interact with them. You'll have to have conversations with them and try to understand how they go about their day-to-day affairs, to basically project to them what is it that you can do when you when you propose your enterprise application solution to them. So this is it's one of the things, right, that we closely encounter as we interact with multiple customers. The other myth is, hey, zero trust is a set of is a product or a set of products. No, right? It's not. As we discussed, it's not that if you install this product you get zero trust. No, right? It's basically about policies. It's basically about your intent to to create a zero trust architecture and work with the multiple pillars of that, as we discussed, right? So essentially it's a strategic initiative designed to stop data breaches. So right, we all know that data breaches are expensive. We attached a cost to that. There's a extensive white paper written by IBM which says it comes close to around $4 million per data breach. And it's essentially a set of principles that allows us to build a secure technology environment, right? This one is interesting, right? Zero trust means you don't trust your employees, right? That's the whole point, right? Zero trust is not aimed at making systems trusted. As we discussed, it's about eliminating the concept of trust from IT systems. There's no trust. It's as simple as that. That's why it's called zero trust. It's not about a person. It's not personal. There is no trust in the system. So that means every actor has to authenticate every interaction. And if the interaction is long, he has to periodically re-authenticate. It's as simple as that. There is no differentiation based on who you are. There is no concept that a certain actor is trusted more than certain other actor, right? The level of trust, the level of authorization is different from the level of trust, right? So there's a difference. So essentially, you are an actor, you have a certain identity, and because of that identity, you get certain access to certain level of access to certain resources. So this is the level of abstraction that we have. Now, who's the actor? The actor can be a user who's logging into a system. He can be a human who's interacting with your system. It can be a client-server interaction between two different machines or two different processes, or it can be an interaction between two different workloads running on the same machine, or as we discussed about the workload identities. So the idea here of zero trust is not to build systems, to make the systems trusted. It's about removing trust from the system, right? That's basically, again, you see, right, you get these pearls of wisdom from these pioneers, and one of that, it says trust is a vulnerability, right? It's a it's a time it's a times immemorial kind of a statement, right? Trust is a vulnerability that is exploited in data breaches. It's we are not trying to make systems trusted. We are trying to eliminate trust from the system. That's very clear. It's a shift in paradigm, and we need to appreciate this point of view, definitely, to understand this. Obviously, there'll be people will have the heebie-jeebies about implementing these things, and it's about making sure that zero trust is not difficult to implement. It's not difficult. It's just about understanding, like we said, if you understand your business needs, everything else kind of starts to fall in place. So zero trust is not, as we discussed, not complicated. It's definitely not more expensive than what happens if your data is breached, right? So basically, again, another pearl, right? It says is a myth that is created by people who don't want you to do it because it will kill their defense in depth model, right? So we all have their different models, right? So it's like it's the same, right? When we look at, for example, when we look at a problem, in this case, it's security. If you live with the problem for a long time, so then that becomes a new normal. And when somebody comes and says, "Hey, I'll remove this problem for you," it creates disruption for many people, many businesses. So they will they will spread misinformation around, "Hey, no, this is very complicated, this takes time, this takes money, it's it's not easy," and all those kind of things. They're all deterrents, right? But the intent here is if you see here, we are coming from a intent perspective. What we are saying is zero trust for me may not be zero trust for you. but essentially the implementation is that what we are focused on is the intent, which then defines all your business decisions, right? So that percolates into the technology choices that you make, series of technology choices that you make, which will make your which will help you build a secure technology environment. There's only one correct way to begin the zero trust journey. No, as we discussed, really not at all. So it's just about putting things together. Where you start from doesn't matter. It's about completing the circle, right? So over time, multiple approaches have emerged. Primarily, one from the security side and one from the identity management side. As you can see, how our the different services that we access have evolved. Essentially, we will see, that identity management has come a long way from where it was to where we are right now. With that, I think I'm done. These are a set of resources that have been very helpful for me in understanding this ecosystem and appreciating the troubles that we sometimes go through when we are trying to access our emails. Like many times when you feel you have to access your email, you just want to, kind of like get it out there. But what happens is your two-factor thing comes and says, hey, type in the password and then give me the OTP, and you will feel irritated, right? But we need to learn to look at the bigger picture and see why all of this is important. And and this kind of digging into these concepts allows us to appreciate the things that are happening around us better. So with that, I thank you for your patience. And Aishwarya, if there are any questions, I'll try my best to answer them.
Absolutely. Thanks a lot, Vikram, for the insightful session. We do have quite a bit of questions where we would want to pick your brains on. So I think without any further ado, we'll get started on that. The first question is around, are there any recommended control checklist for this zero trust maturity model? What are your thoughts on
that? Okay. Yes, right. Definitely, we spoke about the maturity model. And if you see, there are no prescriptions there, right? If you see, there are no prescriptions about technology. There are prescriptions about policies. There are prescriptions about identifying the actors that are impacted, that impact your trust and breaches within a system. So we discussed about the multiple things, right? We discussed about users, applications, network, data. We discussed those things, right? And devices, right? So the point is about the prescription there is about controlling access and ensuring that you verify your authentication authorization about that. There are and once you take care of these, address these different actors, understand how these actors different entities interact with each other, and ensure that all of those individual interactions are secure. For example, when we spoke of data, we said we spoke about data in transit, we spoke about data in rest, right? So if you do everything and you put your data in a disk which is not encrypted, and if that gets stolen by someone, he can access all the data, right? So then what is the use of authenticating, keep on authenticating, keep on verifying your authentication and do everything and put your data in a disk that can, for example, in today's world, you can see, I cannot just plug in a thumb drive to my laptop and copy data to that, right? And you go to for example, you go to your mobile phone, open your Teams and try to copy something from Teams and paste it on your WhatsApp. It does not allow you to do that, right? There is a policy which says this app does not allow you to copy data from here to external sources, right? So it's all about building a well-rounded, secure environment. It's about understanding where data breaches can happen, what are the attack surfaces, and ensuring that those areas are covered.
Got it. Thanks for that, Vikram. The second question is around the Spire. Is Spire open source model, SPIR?
Yes, Spire is an open source model. It comes from one of the CNCF projects. Definitely, I've provided resources around that. You can see here there is a lot of resources around SPFE and Spire. Like I said, SPFE is the protocol that defines how to assign identities to workloads, and using either the certificate-based identities or your JWT-based identities. And Spire is one of the open source project, CNCF sponsored open source project that allows you to use SPFE generated secure verifiable identity documents and gives you an ecosystem to work with them. Yes, so Spire is an open source project and very much alive and kicking. So
there's a follow-up question on Spire. So how does the Spire framework work for a serverless workloads like AWS API Gateway?
Unfortunately, I don't have an answer. I haven't explored that. So at some point of time, I'll once I understand that, probably we'll share it in a different forum.
Absolutely. Thanks for that, Vikram. So
Yeah.
the next question is around the context of trust broker service orchestrating access.
Correct.
How do you think the trust broker service know the lesser access needed for the particular interaction? Is it through the API call service being called from MSA to MSB? What are your thoughts on that?
Interesting question. I spent I don't have a complete understanding of this, but essentially you need to you need to advertise that using metadata. You need to keep see, for example, when we talk of these interactions, right? So we need to have a complete registry of for example, if you take a simple example, some of these calls can be GET calls, some of these can be HTTP POST calls. But typically POST calls, you would, since they do change the data in the backend, you would expect that they have a certain level of authorization. So maybe it comes from that, right? Maybe you can. I'm yet to explore the implementation aspects of this pattern, but it's definitely a very interesting pattern that I came across. I wanted to share, and since I didn't have much implementation experiences in that, I didn't put it in the slides. So yeah, and I haven't explored all the aspects of this, but definitely I think what is required is that we need to build a registry of what are the services that are offered by a microservice, and what is the required level of authorization for that. And that allows your trust broker service to decide whether to reissue a token with a lesser authorization level or not. So that's a simplistic implementation that came to my mind. I haven't explored the finer aspects of that.
Got it, Vikram. So the next question is around, as you know, that most of the companies have moved to a hybrid workplace environment at this point in time. So do you think the zero trust model can keep up in the hybrid work environment?
Absolutely, right. That's the whole point. I mean, some of the aspects of how we see today, like I think so that the whole hybrid work environment is based on this, right? If you see, like I explained, some of for example, I can take some examples from my how I access my Microfocus, some of the data, right? For example, we moved to Office 365. So once you move to Office 365, you don't necessarily need to be on the VPN to access a lot of this data. So what is happening is the enterprises are also moving their workloads to cloud. And when they move the workloads to cloud, your authentication, how do you authenticate? So what I do now is, for example, I go to my SharePoint link. It says microfocus.sharepoint.xxx. And the moment I access and the moment I provide my email, corporate email ID, it takes me to my corporate authentication portal, right? So we are already there. So what do you mean by hybrid? Hybrid means you're accessing data. What I understand is you're accessing data from physically being outside your corporate network. Okay. You're not accessing data being in office from an office network. You are accessing data from for example, you are at your home, accessing data from your Wi-Fi connection or accessing data from your mobile, not on the company VPN. So how do you authenticate and authorize in that? It's already, if the access is there, then you have implemented one level of authentication. Using some of the principles that we already spoke, right? So Google said access to service should not matter, should never be dependent on where you're accessing it from, right? When we looked at the Beyond Corp, one of the principles was that. And we already see that happening. So definitely, I think we are already there in many aspects. If you are working in hybrid mode, if you are able to securely access your data from from any device without having to be on the VPN all the time, then you're already there. See, for example, today, our need to access and get on the Office VPN is limited to accessing for example, our development machines or our build systems that are within our on-prem devices. For almost every other HR service, payroll service, or my office services, I don't need to be on the VPN. I can just access it from anywhere, as long as I'm able to establish my authenticity. And there are ways. Just try not accessing it for a while, and then you will see that you are logged out of there, right? So we are definitely looking at experiencing it in many ways already. So that's see, when I went through this learning experience, that it helped me understand how I work with my enterprise data better as well. So it's not just about microservices architecture, it's also about how I access my payroll services, how I access my HR website, how I access my office documents, how I access my Outlook, how I access my Teams. All of these, when you look at it in totality, you will see aspects of zero trust that are already there.
Got it. So the next question is, I think, the follow-up to the Spire server we just discussed a couple of questions before. Since there's a lot of internal traffic between the workloads and microservices, don't you think it will impact the performance if every request identity has to be verified by the Spire server?
Yes, but like I said, the Spire servers are also available as Kubernetes workloads that can horizontally scale. And this is not like a global server that is providing identity verification for everyone across the world. No, you can deploy your own Spire server. You can size it. You can horizontally scale it to suit your requirements. But definitely, yes, that is a consideration, and I think this framework has explored that to a good level. Though I don't have enough working experience in configuring Spire at scale, so that's for me to explore in future. Yeah.
Sure. So the next question is around what are the few aspects that can be targeted from an authentication standpoint to go towards the zero trust architecture?
Can you repeat that again?
Yes. What are the first few aspects that can be targeted from an authentication standpoint to go towards the zero trust architecture?
Okay, if you are talking about within microservices or for your application, then yeah, there are different aspects we follow, right? For example, we need to, at the simplest, if you're talking about access to an application by a user, you need to implement your password policies, right? You need to implement session timeouts, right? For example, you need to implement. If you look at any banking website, this does it very well, right? If you, for example, if you log into a banking service, if you're logging to, for example, your SBI or Citibank or whatever portal that you use, if you don't show any activity for a few minutes, it will give you a prompt. It says, hey, your session is about to expire. Do you want to continue? So you need to implement those models in your applications, wherein you have to have these aspects of zero trust. Like for example, always verify authentication and keep verifying. Right. So those are some of the things that you need. And if you are implementing a microservices architecture, we can look at implementing your workload-based authentication and authorization that ensures that only the right actors can, only the right services can access. You can essentially tie the interactions within a system and say that service A can only interact with service B, C, and D in this mode. So that's using your open policy agent kind of implementations. So yes, these are some of the aspects that you can explore, but definitely at different levels. So I spoke about first about ensuring that when a user logs in, he has certain there are certain checks and balances there, right? So is periodically you have to. They are all time tested paradigms, right? Like for example, if you go to the OWASP website about session management, it tells you about implementing absolute session timeouts. It tells you about implementing, for example, inactivity session timeouts. There are multiple things, right? So there are ways how to ensure that your tokens are secured. All those things are aspects of moving forward on how to implement zero trust security. So I mean, what is the use of implementing, for example, MTLS and all those things in your backend when when you don't handle session timeouts properly on your for your logged in user, right? If I log in once, if my session is alive forever, then what's the point, right? So those kind of things we need to look at a bigger picture, understand the system interactions, understand who's logging into the system when, for how long, and then things will start becoming clear for us, is what I feel. Yeah.
Got it. Thank you so much for your response, Vikram. We do have a couple of more questions, and I hope that we can take that offline.
Yes,
but with that,
definitely.
That's it we have for you today. And for the ones who are asking for the session recording or for the deck, please drop us a note to events@zinnov.com. We'll get back to you on that. Thank you once again, Vikram. It was an extremely thought-provoking session, and we had quite a bit of takeaways for sure. Thank you so much once again. It was an absolute pleasure to host you. And to the ones who joined us, hope you found today's session insightful. See you in our next Zinnov webinar. Take care and stay safe. Have a great weekend ahead.
Thank you for providing this opportunity to share my learnings with everyone. Thank you very much, Aishwarya.